Today, the second day of the conference has started, and the Dr. Pandrasamy, the brilliant and highly responsible person, is going to give the resources in the topic of outlier detection in big time series. And we are very proud that Dr. Pandrasamy is our alumni of Madurai Kamaraj University. Sir, we welcome you, sir.
Thank you.
Sir, now the session is handed over to you. You can proceed, okay. Sir.
Thank you, madam. So thank you for the invitation from my alumnus institutions, and thank you for hosting this wonderful conference. So I'm going to present today a topic called outlier detection in big time series data. So I'll briefly explain about. So at present, I'm working as a postdoctoral scholar at Singapore. This is my website, so where you can find some interesting research related to whatever the stuff that I am doing. So this is the outline for today's talk. So I will introduce what is a big time series, and then I will also explain about what are all different types of outliers that we can find in big time series data, and then I will give an overview of a list of outlier deductions that can be used to identify outliers. And then I will also summarize some of the open source libraries and tools that is available available for detecting outliers. And for the interest of some of the researchers and the faculty members, I will also give some details about what are all the future research directions if someone wants to pursue outlier detection in time series. Okay, so okay. Okay, let's see what is a time series. So let's formally define what is a time series. A time series is nothing but an ordered collection of observations that is recorded at a specific time. So for example, in the left hand side, you will see a small table in which, so we are recording some value at, let's say, a time 9 o'clock, 10 o'clock, 11 o'clock, like this. Unlike normal data, so every value is attached with some timestamp, so that we can use this timestamp information to identify some interesting patterns in the time series. So the good thing about the time series data is actually it connects past, present, and the future, because we have this the notion of time. Right. So from past, we can identify, what is the, the patterns in the time series. In the real time, in the present, we can identify, some real time characteristics, and we can also forecast this time series value for future. So this has several applications for analyzing time series to predict the future and analyzing the, present. Let's see some example of time series. Okay, let's see what is the temperature in Madurai today. So for example, right now it is showing 33 degrees Celsius, and then the temperature, this is just a forecast of what is the temperature in Madurai. So it is showing that by 2 o'clock the temperature will be 26, and then 5 p.m. the temperature will be 21, like this. So this is an example of a time series. The point is actually we have a time like 11 a.m., 2 p.m., 6 p.m. and there is a temperature value attached to each time instance. Let's see another interesting time series. Okay, so for example, due to coronavirus, the gold price is hiking like anything, right? So this is a plot that shows the gold price in Indian rupees per gram for the past 20 years. So for example, in 2001, the price was like, 500 rupees around. And then around 2011, so it was like 2000 rupees. And then there is some fluctuation. If you see, this is the trend, the blue line shows the trend of this gold price time series. See, if you see between 2012 and 2013, there are some lot of fluctuations. And then the gold price, kind of came down after 2010, 2013, and then it was kind of stabilized, until 2009. And then after 2009, there is a huge spike in time in gold price. The point is actually we can use this kind of time series data to model, okay, for probably, we can forecast what will be the gold price, next year. And then people can kind of, invest on gold or not, right? So let's say what are all the different types of time series? Okay, so broadly we can classify time series as like a univariate or multivariate time series. So basically, a univariate time series will contain observations from a single variable. For example, only the temperature. Okay, a multivariate time series will contain observation from multiple variables. So for example, temperature, humidity, like that. And then the time series also we can classify as whether it is a stationary time series or a non-stationary time series. A stationary time series will follow some statistical properties like the mean and variations will be constant over a fixed time window, and that will continue. In case of non-stationary time series, that is like highly random, so it's very difficult to model a non-stationary time series. So for example, the gold price that we have seen is kind of a stationary time series. Let's say if we are generating some random data, that will be like a non-stationary time series. And then we can also say classify a time series as whether it is a periodic or non-periodic. So periodic in the sense we collect a sample at a fixed interval. So for example, the weather data, so they have reported the weather data at a fixed interval, right? Every 1 hour they are collecting this weather information. So in case of non-periodic, mostly the events that may happen anytime. So there is no periodicity. It doesn't repeat actually. It does not occur, on every day or every hour or like that. And then let's see what are all the components of a time series. In general, a time series can be, decomposed into 3 sub-components. So those components are called a trend, seasonal, and the random. Okay, so the trend will give us what is the overall trend of the time series. Is it like it's increasing or it's decreasing? So for example, the gold price again, so it's increasing from 2000. Right, so that's the trend of the gold price time series is increasing. So and then there is a seasonal component. The seasonal component will tell us the cyclic behavior of the time series. So for example, let's say if we consider the weather time series, so the seasonal will be on a daily basis. Okay, so in the morning we'll be having lower temperature, and the afternoon we'll have a high temperature, and then evening we'll have a lower temperature, and this kind of pattern will be keep on repeating every day. So this is called a seasonal, and that this seasonal will contain a cyclic behavior. Some time series may not contain a seasonal behavior or a cyclic. Okay, and then there would be a random noise that is added to this time series. So that will denote the fluctuation in the time series, based on different contexts. The point is actually we can, this is an additive components of a time series. If we add all this trend, seasonal, and the random time series, we can get the observed time series. All right. So this will be useful for identifying some interesting patterns in time series. And then let's get into what is a big time series today. Okay, so there are people started to install a lot of IoT sensors like smart meter, temperature sensor, humidity sensor, air quality sensor. So all these sensors are generating data like anything. So they are sampled at every minute interval. They are generating a lot of data. And also with the advent of social networks, so we are also generating a lot of data. Like, so whenever we we post something on a Facebook, or when we post a message on a Twitter, or whenever we like or share something, all these are an example of time series data only. And then with the advent of social networks, so we are also generating a lot of big time series. When I say big time series, this is like millions of samples generated every day. Okay, and let's say, so how can we visualize this big time series? In case of a normal time series, we can easily visualize. Let's say it's a few hundred readings. We can clearly, plot, plot some time, plot a line chart, and we can easily see that. So here I'm showing an example of a smart meter data. A smart meter is like it's like a traditional meter that we have in our house, but the advantage is that it can generate data at a fixed interval, like 1 hour. 1 hour it can take a reading, and it will send that to the smart grid. Okay, so what you see here in this figure is an example of a big time series. So this is just for 1 year, but if you are collecting this kind of data for several years, this data will be looking very large. Just for illustration, I am just presenting 1 year data. So this is for from January 2016 to December 2016. So in the x-axis you see the month, and then the y-axis you see the power consumption from an example school buildings. Okay. So you can see some periodicity and the cyclic behavior in this big time series. You see there are spikes that is coming up and down, right? So these spikes are corresponding to like weekly consumption, and those not spikes, that white caps in between are like weekends, because weekends these schools are not operating, and only during the weekdays these schools are operating, and that is why we have these spikes in between. And also you can see some anomalous kind of behavior around September mid. We will discuss that in detail. So this is visualizing a big time series using a traditional line chart. But if we really want to get and understand some pattern from this time series, we have to use a different visualization techniques. So what you see here is a heat map for the same time series. So here what you see is actually, instead of plotting every data point in a line, so I'm plotting them as a heat map. In x-axis you see the day. So each day will contain one vertical line, and then in that vertical line you'll have small tiles, and that color corresponding to that tile will tell us the value. And then y-axis is the hour of the day. So for example, if you take this May, let me show you an example. Okay, so here you see there is if you see the hour of the day from 0 to 23. So in the morning there is less energy consumption, and then during the mid time, like from 7 o'clock to evening 6 o'clock, there is higher consumption, and that is why the color code for that particular cells are it's yellow or red. And then in between we also have this light dark blue color vertical lines that corresponds to the weekends. Okay, and then so for 1 day, if you see, okay, there are some energy consumption during the night hours also. Probably there was some activities going on the school, or that could be an anomaly, like people might have forgot to turn off some appliances. And also you can see in general the power consumption during the summer will be high, because people started to use more air conditioning or the fans, and that is also clearly visible in this figure. The point is actually the normal line chart or the traditional methods may not be useful to identify all these patterns. So, and that is why we use this kind of heat maps to identify some of the patterns in the time series. So here is an example from multiple meters. So from 4 meters, so you can easily see some patterns. For example, in the second meter, from month January to May, so there are some activities. There is some shift in the activities. Probably they started operating the schools from 6 o'clock to evening or afternoon 2 o'clock. So we are clearly able to see all those patterns, and then they are back to normal, like from April to June in the second for the second building, like this. For the third and the fourth meter, we are mostly see a similar pattern, like too much energy consumption during the summer, and there are some anomalies in between. Okay. So now let's see what are all anomalies in time series. Okay, so by definitions, an anomaly is like an observation that deviates, somewhat, that deviates significantly from, some neighboring points. Okay, so there are several reasons that this kind of anomaly could occur in the time series. Probably a measurement error or human error, like people, type some wrong information. For example, if some person is going to collect a weather information, he mistakenly typing a wrong temperature information, that could be an anomaly. Or the devices or the networks that we are using to collect this time series data, that got failed. Right, so in that case also we might be getting this kind of anomalies. And there could be a number of other reasons. Okay, there could be a natural phenomena that is also, that might be also generating a time series outliers. Okay, for example, in this plot, there's all those blue lines are like a normal, and there is this pink spot. Okay, the value went all of a sudden high. Right, this is an example of an outlier. Okay, let's see what are all the applications of outlier deductions. Okay, so the some of the applications include, like, credit card fraud deduction. Let's say if we are keep on using credit card, and all of a sudden if the bill is higher for some reasons, or somebody might have stolen our credit card and they are using it for some other expenses. So this kind of things in banking, they use outlier deduction methods for detecting some frauds. In networking, particularly, people use outlier deduction methods for intrusion. Let's say there is some hacker, generating some artificial traffic, or he is stealing some data from a network. This kind of anomaly detection methods can be used to detect them. And then in industry applications, people can use anomaly detection methods for identifying faults. Let's say that we are using some an equipment, so that generates faults due to higher temperature or some fluctuation in the power consumption or something. So in case of healthcare, so the ECC monitoring is a very good example of outlier detections. So we can use this to identify some abnormal pattern in the ECC to identify there could be some potential risk for heart attack or any other diseases. Now let's see what are all the different types of outliers. Okay, so in general, these outliers can be classified into three types. The first one is called a point, and the second one is called a subsequence, and the third one is called contextual. Okay, let's see what is a point outlier. So a point outlier is actually in a given time series, there is a single observation that looks unusual. For example, in this figure, there are all those red dots are an example of point outliers. So the time series goes like it goes up and then it comes down, and again it goes up, but in between there are some single points, that is the value is too much high or too much low. So this is an example of point outlier. Now let's see what is the subsequence outlier. So the subsequent outliers, it's also called a collective outlier. A sequence of data points looks abnormal. Okay, so for example, this is an example of ECC data. So in general, you see this spike, right? So there is a fixed pattern, but all of a sudden that spike is not coming, or there is some delay in between. So these data point, these time series stay at that particular time for some time, and then it is started back. So this is an example of a collective or subsequence anomaly. And then there is a third category called contextual anomaly. So a data point might looking normal, normal in a particular context, but it may looking abnormal. So let's consider this monthly temperature for one year. Okay, so in general, the temperature is lower sometime December, but all of a sudden in June, when there is huge temperature, but only that point the temperature went down. Okay, so this is an example of contextual anomaly. So that is actually a data point might look normal in one context, but it is an anomaly in another context. Okay, so in addition to these three types, there is another broader category called local and global outliers. So local outliers are like, there is some pattern which is local to its neighbors. Okay, it's local to specific neighbors. Okay, but there are global anomalies that is, that will be present throughout the time series. Okay, so this figure shows an example of local and global anomalies. Now let's get into the actual anomaly detection method. Okay, so what is an anomaly detection? This is the process of detecting outliers automatically. So we need to come up with some model or some algorithm to detect these outliers automatically. Okay, but there are several challenges to detect outliers. Okay, the first challenge is actually unavailability of labels. Like so whenever we collect some time series data, we may not collect any information about the outliers, right? So let's say if you are collecting some temperature information, so we will assume that okay, the temperature will be keep on coming normal, but we may not be collecting when that anomaly might happen. Okay, so in case if we want to collect anomaly labels, that is also very difficult to collect, or we need to inject some anomalies. Okay, and the next challenge is actually what are we going to model, or what pattern we are going to understand to differentiate outliers. Are we going to model the normal behavior of the system or the outlier? Okay, so there are two cases, and then the data might have inherently some noisy data, so that might look similar to an outlier, but we need to differentiate that. Okay, and there could be a concept trip. So what is a concept trip is actually the power consumption, the time series trend will be positive some period of time, and it may go back to a negative directions. So we might need to consider this fact while detecting outliers. Okay, and there could be particularly in real-time anomaly detection. So we are supposed to detect an anomaly, so whenever that occurs. Okay, so if you are detecting an anomaly earlier, probably that might lead to a lot of false positives. So we need to balance between early detection and false positives. And then the another challenge is actually, so are we going to detect this anomaly in batch mode or in real-time mode? So accordingly, we might need to use different methods. So here is an example of a point outlier detection method. Okay, so the problem means actually we have x of t, that is an observed value at particular time t, and then so we'll have an expected value. So what should be the ideal value at that particular time, that we denote as x cap t. Okay, so the difference between these two, like observed and the expected value, is greater than some threshold. So we will consider this x of t as an outlier. Okay, this is a very simple definition. Okay, so for example, in this figure, all these data points like O1, O2, O3, O4 are an example of outliers. If you see the expected value at that particular time is, the expected value is given as a gray color box around that data point, and but these data points O1, O2, O3, O4 are looking higher or lower than the expected values. Okay, so this is the general setting for detecting point outlier detection. Okay, and we have several methods based on this framework. Okay, so these point outlier detection methods can be like, it can be a model based. So basically we will develop a machine learning model that will represent the normal or abnormal behavior of the time series. And then this model based method also can be two types. It could be a estimation based, or it could be a prediction based. And then there is a second type of outlier, point outlier detection. It's called density based. And then the third one is called histogramming. Okay, so but in this talk, for the sake of time, for the interest of time, I will mostly focusing on model based methods, particularly the prediction based model. Okay, so let's see what is the difference between estimation and prediction based method. Okay, so let's consider this is an example time series. Okay, so in case of estimation based method, what we will do is actually, so we will consider the current timestamp, current data, and the past and the future. Okay, so we will define a time window, and that time window will contain data from past, current, and the future. And based on these values, we will estimate what would be the expected value at that particular time. Okay, so in this figure, that yellow color window is an example time window, so that covers both the previous value, the current value, and the future values. This method, estimation method, is more suitable for analyzing historical time series. That is, we already collected the time series, and we just wanted to identify at what time anomaly has occurred. Okay, an example of estimation based method is median absolute deviation. So basically, for the given time window, we will calculate the median absolute deviation, and then that value is different from the actual value. We will say that, okay, that's an anomaly. Okay. Okay, so in general conversation, the terms outlier and anomaly are like interchangeable. So there is no a difference between them. then the next category is called a prediction based. So in the prediction based method, what we'll do is actually we'll focus on historical data only. So let's say at time t, if you want to identify whether that particular data point is an anomaly or not, so we will collect all the historical data, and then based on the historical data we will develop a machine learning model, and that model will forecast the value for the current time. And then if the difference between the actual value and the forecasted value differs significantly, then we will say that the current value is an anomaly. Okay, so an example of prediction based method is, it's called ARIMA based method. Okay, so there are several statistics based method for our prediction. Okay, so this kind of prediction based method are actually more suitable for real-time data. So because we already have collected all the historical data, so whenever a new data comes, then we can apply this prediction model, and then the prediction model will give us the new data, and we will compare, and then we will tag whether that particular data point is an anomaly or not. Okay. So there are most of the research around outlier deductions are based on prediction based model, particularly using machine learning based methods. Okay, so this is another another way of detecting anomaly. This is called a signal reconstructions. What we will do is actually, so we will get the original signal. For example, here this is an example of like a ECG. Okay, so using machine learning model, we will feed all this historical data to a machine learning model, and then the model will recreate the signal. Okay, so basically, how that signal would be looking for a given time frame. Okay, and then what we'll do is actually we will find the difference between the reconstruction signal and the original signal, and is there any difference, then we will tag that as an anomaly. So in this case, the original signals, we have this periodic spike, and then using some efficient algorithm, we are reconstructing the signal, and then we are finding the difference between these two. And if you clearly see at time point around after 101, there is a spike in the original signal, but in the reconstruction it is not able to capture. It is not able to capture, and then the difference shows there is a spike, and we can tag that is an anomaly. Okay, and specifically for big time series, so we have a lot of deep learning based methods. I'm not covering some of the traditional methods, traditional machine learning based methods like ARIMA or any other statistics based methods. Okay, so specifically for big time series, there are a lot of deep learning based models. So one of the deep learning based model is called a variational auto-encoder. This is also similar to a reconstruction method. Okay, so what we will do is actually we will get the original time series. So we will transform this time series into like based on the application domain, we will transform that into different values. That transformation could be an FFT. It's called a fast Fourier transform, or it could be a wavelet or any other standard methods for transferring time series. So once we get this fast Fourier transform, so we will feed that into an auto-encoder network. Okay, so the way this auto-encoder network is actually, so it will take input from this transformed time series. Okay, it will map that into a low dimensional space. So that is why we have less number of neurons in the middle layer. Okay, so this is a very simple representation of a variational auto-encoder. But in a typical setting, we may have the encoder network itself will contain several layers, and then the decoder network also will contain several layers. So in this example, we have just one layer for encoder, and then the one layer for decoder, and in between we have this intermediate layer. Okay, so the point is actually this encoder will transform the given input transformed time series into a representation. It's like a compact representation of the original time series, and then the decoder job is actually expanding this compact representation into a expanded time series. Okay. We need to train this autoencoder with large amount of time series so that the both encoder and decoder can work properly. Okay, so once we are able to achieve a decent accuracy in in training this autoencoder, so for the new time series we will feed that new time series, and then the decoder will generate the reconstructed time series. Okay, and then we will see what is the difference between the original time series and the reconstructed time series, and if there are any differences, we will tag that as an anomaly. Okay. So in the right side, you see an example of how is the normal data looks like and what is an abnormal data looks like. Okay, but there are some problems with this variational autoencoder method. So the problem is that, so if our autoencoder is not generic, okay, so let's say it is tuned for a specific time series, right? It's kind of over training, right? In that case, it will generate the reconstruction times. The reconstructed time series might be looking significantly different from the original time series. In that case, there could be a lot of false positives generated by this autoencoders. Okay, but there are ways. We can mitigate this problem. We need to do a lot of cross validation using this autoencoder, and so that the autoencoder can work very well. And the next topic within this deep learning based outlier detection for big time series is called LSTM. It's called a long short-term memory networks. So here also, instead of using this encoder and decoder, so we will feed this time series into a big LSTM network. So the advantage of this LSTM network is actually it can capture the the interrelationship, the temporal relationship within the time series. So basically, this is what I presented earlier, right? So like what is the trend, what is the cyclic behavior, and what is the noise. So all those properties this LSTM network can capture. Okay, and we need to develop the layers for this LSTM network accordingly. A separate layer to capture the overall trend of the time series, and another separate layer to capture the seasonality of the time series, and there could be another layers to capture the the noise in the time series. So this is a simple example, but in a practical setting, this LSTM network will contain several layers up to up to even 100 layers, so that the network will work in a better way. Okay, so the setting is actually we'll get this raw time series data. So in that case, transforming these time series into a different representation is an optional, and we will apply some pre-processing method to filter out some noise or some values, and then we will feed this time series into a LSTM network. The output of LSTM network, so we will apply some threshold based on the prediction value. If that threshold is higher, the difference between the actual and the difference is higher, then we will tag that as an anomaly. So the overall the framework is particularly for point anomaly detection is, so there is an observed value, there is a predicted value. If that difference is significantly different, this one, okay, there is an observed value and then expected value. If the difference is significantly different from a threshold, then we will tag that as an anomaly. Okay, but one of the problem with this point outlier detection using this kind of framework is that actually it's hard to detect this threshold. Okay, in some settings we might need to use based on some visual analytics, we can easily detect we can easily come up with a threshold that is more suitable for a particular time series, but it may not work for a different time series. Okay, so one of the limitation of this point outlier detection using prediction based model is coming up with an optimal threshold. Okay, so next there are some more advanced deep learning architectures. It's this is one example called a multi-cut CNN-RNN architecture. So this is a combination of convolutional neural network and a recurrent neural network. So this is an example for a multivariate time series. Okay, so for in the left side you can see a sample time series from 4 sensors. Okay, sensor 1, 2, 3, 4, actually 5 sensors. Okay, and then for each sensor sensor, we will apply a 1D convolution, and then we will flatten that, and it will contain a CNN network for each time series separately, that is for each sensor, and then we will concatenate all of them into a RNN network. The advantage of RNN network is similar to the LSTM. It can capture the temporal variation in the time series. Okay, and this RNN network will give us the output, and that we will match with the original time series to see is there any anomaly or not. Okay, so there are several advanced CNN, basically a combination of CNN RNN architecture, a combination of CNN and variational auto-encoder methods. So even some more advanced methods use called a network architecture called GAN. It's called generative adversarial networks. So the purpose of generative adversarial networks are for a given time series, it will train it will understand all the characteristics in the time series, and then it can regenerate some time series based on whatever the input we give. Okay, so I'm not going in detail into the GAN models for time series, but you can easily find some papers on the internet. So, and then I'm also going to briefly discuss about, so what is the practical utility of this kind of anomaly detection system? Okay, I'm just picking one use case of, what Microsoft is using as a service in their Azure web services. Okay, so they call this as a time series anomaly detection service at Microsoft. So the interesting component of this system is actually the middle layer. In the middle, what you see here is actually, so they use a streaming broker called Kafka, so to aggregate the data from multiple data sources, and then there are some batch processor, and then the streaming processors, and then there are anomaly detection models. They are pre-trained within their system, and then these anomaly detection service processor also provide some APIs that can be used to identify the anomalies. And they also have a alert service. So whenever there is some anomaly occurs, we will get some alerts based on the priority levels. Okay, the point is actually these kind of anomaly detection services are becoming ubiquitous, and they are going to be integrated with several systems in future, like online shopping or any other system. So these kind of system they have already integrated with banking system already, and for industry applications also they are trying a lot of methods to integrate. Okay, so you can find more details. This is an interesting work on anomaly detection from Microsoft, because everybody can use similar to the way we are invoking some HTTP API calls from their service. Okay, so there is a separate research paper on this one. I'll share that later. Okay, so next I will briefly discuss about some of the open source libraries for anomaly detections. So, so instead of developing some of this model from scratch, we can make use of these open source libraries, and they are mostly public, and we can use it. Okay, so the most common and the widely used is called Twitter. They came up with an anomaly detection package for R. So their package is it is a very robust outlier detection method for time series. So their method is based on a seasonal hybrid EST model. Okay, and there is another package. It's called Anomaly Detection Toolkit. This is available for Python. There is another tool called Anomalies. It's called a TT Anomaly Detection. So this is also available for R. Okay, and there is a benchmark called DeepADTOs. So this is an evaluation and a comparison of different deep learning methods. So if you go into this system, DeepADTOs, so we can they are comparing the performance of several deep learning based methods like auto-encoder, LSTM, RNN networks, and they present a comparison benchmark using standard data sets for anomaly detection. So similar to this DeepADTOs, so there is another benchmarking system called Numbato Anomaly Benchmark. So this is one of the widely used benchmarking system. So they are also comparing the performance of different different LSTMs and methods. They one of the interesting thing about this NAP benchmarking system is that they provide a method for calculating automatic threshold. As I mentioned earlier, so detecting a threshold for a particular setting is very difficult, because if we select some values, it may work for one time series, but it may not work for another. Okay, so this NAP benchmark provides some methods for detecting automatic threshold. Okay. And then finally, so I'm going to give some high-level research directions. I believe that might be useful for some of the students and the faculties who want to work on this anomaly detection. So particularly, so people have tried this anomaly detection for time series, but still there is limited work on streaming data from IoT sensor data and the social networks. So so people might try applying anomaly detection methods for streaming data. So there is a relevant area, it's called novelty detections. Let's say there is some sensor or there is some equipment that is generating this time series. Let's say it might undergo different stages. Okay, so can we detect those stages, program it using machine learning methods? That is called a novelty detection. If at all if the device undergoes some other changes, let's say if you are reconfigured that device, okay, so can we detect all those things automatically? Right. So there are some research coming up on this idea of novelty detection. Okay. And then there is an interesting direction of, it's not just using the time series, combining time series with the spatial data like a location. Okay. So the outlier detection for spatial temporal data. So for example, let's say whenever we make a trip using Ola or Uber, so they collect all this data, like, what time we are picking up the cab, and then, they collect all the GPS coordinates attached with the time. Okay. This is called the spatial temporal data. So can we deduct outlier from this spatial temporal data? Like, let's say if your driver is taking a different route, which is which will cost more money for us, then can we detect all those illegal routes that these drivers might be taking, or that could be a genuine one. Okay, so this is also an interesting direction in outlier detection. Okay. And finally, there is still this field is very new. It's called explainable or interpretable outlier detection. Okay, so here the focus is actually, so let's say we detect an outlier. Okay, so the system is going to give us, okay, this is an outlier, right? But if we want to understand why that outlier has occurred, right? So if we want to identify what is the root cause of that particular outlier, and also can we explain why that particular model is, telling us, okay, this particular data point is outlier, or okay, so can we answer all these questions? Okay, so there is a related to machine learning, there is a new discipline called explainable artificial intelligence. So that is also coming up. So this is like a merging outlier detection methods, explainable artificial intelligence methods, so that the detected outliers can be really useful for the people who are using this kind of system. Yeah, so with that, I conclude my talk, and if you have any questions, I'm open to answer. Thank you all. Madam, I'm not able to listen to you.
Yes, sir. Yes, sir. Sir,
Okay.
queries are in chat window, sir. Please.
Okay. Chat. Okay. Yeah, they are just thanking messages. I don't see any questions. So in case if you have any questions, you can write an email to at. I'm just sharing my email ID. So if you have any question related to this talk, and you can.
How do you confirm the efficiency of NS of abnormal or anonymous on image cover sensor due to the range of temperature? One question. Then how do you conclude to show research paper on this reference journals? Saravana Kumar. I think. Hello, sir.
Okay, yeah. Madam, can you ask that question again?
How do you confirm the efficiency of abnormal or anonymous on image cover sensor due to the range of temperature?
So what is the image cover sensor?
Yes, sir. Saravana Kumar have posted this question.
Okay, but I'm asking what is an image cover sensor?
Anonymous on image cover sensor, abnormal or anonymous?
Okay, I'm reading that question. How do you confirm the efficiency of NS of abnormal or anonymous on image cover sensor? I don't understand what is an image cover sensor, right? So due to the range of temperature, how do you conclude to show research paper on this reference journals? Um, I'm not sorry. Unfortunately, I'm not understanding this question. Okay, can you provide more information about what is an image cover sensor?
Saravana Kumar, sir, are you audible, sir?
So first thing, okay, just to give you some idea. So the work I have presented is mostly for time series data, specifically for numerical data set. Okay, so a time series may contain, categorical or text data also. So we need to have different set of methods to work on or to handle the non-numerical data. But I think he is referring to some image data set, and this kind of methods are not suitable for image processing, image related data sets.
Sir, one more question, sir. As you have stated that ARIMA.
Right.
What is that statistics, sir? What about that?
Okay, so this is a very standard statistical method. Okay, I thought people might be aware of that. Okay. So ARIMA is called auto-regressive and moving average method. Okay, you can usually Google it and you can identify some information about it. So this is a very old method. It's called auto-regressive and moving average method. So generally, people will use ARIMA-based methods for weather forecasting or any task related to weather forecasting. People will use, that's the first method people in general they will try, because it is a combination of auto regression and the moving average.
Okay, sir. Thank you, sir. Thank you very much for your wonderful talk about the outliers of time series. And you have given a great explanation about the process of detecting how to detect the outlier automatically and how it can be overcome the false positive rate. And sir have pointed out the outlier of the detection techniques. So what are all the detection techniques are available, and he explained clearly about the estimation based on the historical time series, how to predict and how to estimate the historical time series. And basically initiated about the machine learning model also, how to by usage of these outliers time series, how the machine learning model can be developed. So very nice presentation, sir. Thank you very much. Thank you for your wonderful talk.
Okay, thank you for hosting me. Thank you all.
Thank you, sir. Next, the technical session will start. Pandrasamy sir, thank you.
Thank you.
Thank you very much. I welcome Dr. Santosh.
Santosh name la illa sir, illa madam yaru.
Ipa vanduruvar sir. 2 minutes. Students, please get ready. Participants, please get ready for presentation. Srinivasan sir.
Solunga madam.
Can you play the recorder mode?
என்ன மேடம்?
அந்த ரெக்கார்ட் மோட்ல உள்ள ஒரு PPT பிரசன்ட் பண்ண முடியுமா?
அந்த
ப்ளீஸ். ஒரு ஜிமெயில் ஃபோன் அடிச்சோம்னா கட் ஆகும், அது வேற.
Greetings to all. The topic of my presentation is current trends and recent advances in detection strategies of viral gastroenteritis. Let's begin with the introduction. Well, we know that diagnostic approaches are important for timely containment of infectious diseases and mitigation of public health risks.
Srinivasan sir, you can present the next video. This already it was over.
Acute viral gastroenteritis is more common than bacterial gastroenteritis and therefore is an issue of concern.
Greetings to one and all. This is Guru, Assistant Professor from Department of Management Studies, SRM Valliyamai Engineering College, Chennai.
Is not going to be run. Even the present scenario, even for the COVID or maybe any virus affected people also analyzed with help of image processing only.
Sir, play ಆಗಲ್ಲ sir. Srinivasan sir.
இந்த ஒரு நிமிஷம் மேடம்.
Places, even traffic monitoring, error identification, or maybe it going to be used in medical image analysis, weather and forecasting. So in every place we can able to see the advantage and the usage of the image processing. So but in image processing, capturing of images is very easiest to work, because nowadays if any user, they may have smartphone, they can easily capture the image, but the quality of the image is a big question mark here, because any user and any untrained user, they may easily capture the image, but if you can see the quality of the image, if you can see the quality of the video, it may be the great question mark. So if your image is not captured in a good quality way, very sure your analysis also not going to lead a good results also. So it is very important, if even though if you capture the unquality image, or if your image is consisting of even some noise, that noise need to be removed before if you are doing any analysis. So the noise removal is one of the most important operation in your image processing system. So in this particular paper, we are going to discuss how the noises are going to be removed in your images. That only we are going to discuss. So already I told you the purpose of this paper, it helps to remove the noise from the images. Your question may come, maybe if there is no noise removal technique so far, no, I didn't say in that way. There are n number of techniques are there. But how this technique is different from other technique means very simple. The technique, it allows the user remove the noise in a step-to-step fashion manner. And each and every step, there are different pre-processing techniques that take place so that every step, a particular types of noise going to be removed, and one final, you will get a fine-tuned images. In other existing systems, the noise are going to be removed by using only one step process only. But this particular proposed technique, the noise are going to be removed into step-by-step process. Each and every step, the noise removed into noise removed, and finally you will get a very fine-tuned images. So already I told you the importance of noise removal because the capturing of images are very easy, but if you can see the quality of the image, very sure, we cannot give any guarantee the quality of the image because even any untrained user, even nowadays the kids also play using the smartphone. So the kids also, they can easily capture any images, or the untrained, unprofessional users also capture the images. But the question here, whether the captured image having high quality or not. So in this high quality or not, or maybe we are going to say that if there is any noises are there, that noise are going to be removed. So here, this particular screen, it's shown that one particular minute, how many of the information, how much informations are transferred in the Google, or how much informations are transferred on the internet, we may really we get surprised. So we
Good morning, sir. Santosh, sir.
Sir, Santosh sir.
Yes. Santosh, sir, am I audible, sir? Or mute unmute.
Hello, good morning, ma'am.
Good morning, sir. We welcome you to Madurai Kamaraj University of the first international conference of the recent developments in science, engineering, and information technology, sir. Now we are starting the technical session, and you are as a session chair for the session, sir. No, I think now we can start the session. The participants are ready, sir.
Okay, ma'am.
Srinivasan, sir, now the abstract ID is 20 SEIT 14. You can activate those numbers, sir. Srinivasan, sir.
Sorry, madam. Sorry.
Participant Megha V. Rajkumar can present their concept. Pa.
Yes, ma'am, I am ready.
Yeah.
Am I audible?
Yes, ma,
Yes.
you are audible.
Okay.
You can present.
My name is Megha V, doing PhD at Department of IT, Kannur University. And I will share my presentation. My study titled Panoramic Image Stitching Using Cross Correlation and Phase Correlation Methods. Image stitching, outline of my presentation includes these contents. A panoramic photo allows a wider view of a scene that is not possible with traditional photography, which includes only a limited view. Image stitching or image mosaicing is the process that combines more than one images of the same scene captured from different viewpoints to form a high resolution single image known as the panoramic image. To perform stitching of more than one images into a single panoramic image, we need to identify the exact overlap between these images. So, image stitching process can be accomplished in 3 steps: image registration, calibration, and blending. Image registration is the primary step in image stitching. It is the process of matching and aligning 2 or more images that may be taken at different times or from different sensors or from different viewpoints. And image calibration is used for eliminating the optical defects such as difference in the exposure, lighting, illumination, etc. And image blending is used for removing the seam after image stitching, that is the seam present in the stitched image, that is in the panoramic image. General methods for image stitching. Image registration can be accomplished in 2 ways. Generally, image stitching can be categorized based on the type of registration applied. Image registration generally classified into direct alignment based and feature based alignment method. The direct method uses pixel to pixel matching for image alignment, whereas in feature based technique, features of the images are used for registration rather than the pixel values. Our work proposed a basic image stitching algorithm based on the direct image registration. The proposed methods are based on cross correlation and phase correlation methods. Both of these methods are pixel based methods, that is based on direct alignment. Cross correlation based stitching, it is a basic approach for image registration. It mainly used for template matching or pattern recognition. It gives the measure of degree of similarity between an image and a template. Generally, a template image is a small portion of an image. Cross correlation between 2 images. For example, consider a template image P of XY and a source image I of XY. The cross correlation can be performed as given in the equation 1. Here, C of UV is the correlation ratio between the template image and target image. It is the degree of similarity between the template image and source image. Here in our work, we use the idea of template matching for finding the overlap between the input images that is to be stitched to form a panoramic image. Here, template image, we need to find the location of the template image in the source image. For that, we use correlation function. The correlation function returns the degree of similarity between the template and source. So, initially, we do not know where the template is located in the source image. So that we need to shift the template image in different positions in the source image. Finally, at the position where the template exactly matches, it gives the maximum correlation ratio. We need that maximum correlation ratio. Finally, we will get an output image with the location XY. which have the maximum correlation ratio. This is the idea behind the template matching. The methodology used in the cross correlation, it can be used as a similarity measurement. They assume a linear relationship between the image intensities. That is, images are varied only just by translation. In our work, we captured one image just by shifting the camera in X direction or in Y direction only. The aim is to maximize the cross-correlation ratio of the two aligned images. In the proposed method, 3 input images of the same size are used for stitching. We proposed 2 separate algorithms for stitching images having horizontal displacement and vertical displacement. Image alignment and blending. After finding the common area in the input images, after cross correlation, we need to align the input images. Image alignment and blending are the final step of image stitching. We aim to stitch 3 images of the same scene into a single composite image. A linear relationship exists between the input images. Input images are captured by varying horizontal or vertical positions. Two-dimensional translation operation is needed to align the input images. The flowchart of the proposed work using cross correlation can be explained as: first, we have to read the 3 input images. Next, normalize each images. Normalization means if the input images varies in the exposure, then cross correlation cannot find an exact match. So we need to map the brightness and exposure into the normalized value. After that, we create a patch of first 2 images. Here, the term patch means same as the concept of template. Patch is a subportion of the source image. In our work, we used a 5 by 5 patch size. After that, first patch is cross-correlated with the first patch of the second image. From the maximum correlation ratio, the cross-correlation is performed iteratively, and from the maximum correlation ratio, the common patch can be located. And after that, after locating the common patch between the first 2 images, we can calculate the horizontal displacement or vertical displacement. After that, align the first 2 images by applying translation operation. Then we get the first stitched image from the first 2 images. The same operation is repeated with the third image. That is, create the patch in the stitched images and the third image, perform cross correlation iteratively in different positions, and locate the maximum correlation ratio position. That will be the common overlap between the stitched image and third image. After that, align the first stitched image with the third image. Finally, we will get a final stitched image, that is the panoramic image, from the 3 input images. And the one of the limitation of the cross correlation method in the proposed algorithm is that it is not invariant to scale or rotation. Also, it can handle only horizontal translation or vertical translation simultaneously. Both cannot handle. We proposed another method known as phase correlation based stitching. It can handle images having both horizontal and vertical shifting simultaneously. This limitation can be overcome. It can be used for stitching images with both, and phase correlation between 2 images can be calculated as given in the equation, where C is equal to F1. F1 is the Fourier transform, and element-wise product between the Fourier transform of second image. We will get the common overlap between the input images. Results and discussion. The algorithm discussed, 2 algorithms are implemented in MATLAB, and we created different data created a data sets consisting of different set of images of books, keyboard, face, building, and outdoor view. And using cross correlation method, 3 consecutive images are stitched, and using phase correlation method, a pair of images are stitched. Here it is the cross correlation, horizontal displaced image. Here we captured the first input as given in the first figure C. First input image is captured and second input image is captured by just shifting the camera in the X direction only by constant Y position. And third image is again captured by shifting in right X direction. We got the stitched image after performing the cross correlation. The same algorithm is repeated with the images of keyboard. Images are captured in the same way as given in the first set. And vertical displaced image. In vertical displaced image, the first image is captured and the second image is captured by just shifting the camera in the Y direction with a constant X direction. Finally, we got the stitched image from the first two input images. Here, you can see that both images contain an overlapping area, but in the output images only it is present only once. That is, our main aim is to locate the overlap area and remove it in the final image. And phase correlation based stitching, it can handle both X, as already told, it can handle both X horizontal and vertical direction. As shown in the figure, first image is captured and second image is captured by shifting the X direction and Y direction. I think it is not clear in the image, but it varies in both X direction and Y direction, the second image with respect to the first image. Finally, we got the stitched image, but you can see that a blank area is present in the final image. That is the one of the drawback of the phase correlation. So image inpainting algorithm is needed to fill this blank area. The correlation based algorithm works well in the case for stitching images that are varied by translation. To stitch image that are either horizontally displaced with each other or vertically displaced. To stitch two or more images having both horizontal displacement and vertical displacement, for phase correlation based stitching is suitable. Conclusion, the proposed cross correlation based stitching algorithm is aligned together by calculating the offset between the matched patch. This is the basic level of image stitching that can be applied for adjacent disordered images. Phase correlation algorithm is well suited for stitching images both horizontal and vertical displacement. We conclude this paper by stating that the correlation-based image stitching and phase correlation-based image stitching are translation invariant, but not scale and rotation invariant. As a future work, more sophisticated algorithm is to be created to overcome the limitation occurred in these two approaches, that is for scale invariant and rotation invariant to stitch images. And these are the references of our work. Thank you.
Okay, nice presentation.
Okay, sir.
Explain what is meant by cross correlation.
Correlation, it compares pixel by pixel. It is the degree of similarity between, basically it is the degree of similarity between two pixels.
So what is the difference between correlation and cross correlation?
Generally,
You said that your work involves cross correlation.
yes, sir. Correlation, there are cross correlation and normalized cross correlation, etc. Here, I used the cross correlation concept. It is there is no huge difference between correlation and cross correlation. It is the product degree of similarity between two pixels.
Okay, in your you mentioned only proposed work in your presentation.
Yes, sir.
What about the existing work? Have you compared any? Have you done any performance analysis or comparative analysis with the use of MATLAB. You stated that you have used MATLAB in your work.
Yes, sir. The current
So
work.
have you compared any existing approaches with your proposed method?
No, sir. Currently we are working in the pixel-wise operation and feature-based method, but I did not compare any two works, sir.
Okay, if you compare, you can then only you can say that your proposed methodology is well and good.
Yes, sir.
Okay, thank you.
Okay, thank you, sir.
Thank you, Ma. The next candidate, Sobana. The participant Sobana can get ready.
Stop screen sharing.
Shobana, optimized multi.
Good afternoon, one and all present here. Giving this opportunity. Ma'am, can I start presenting?
Yes, yes, sir.
Am I audible? Am I audible?
Yes, you can present.
Is my screen visible?
Mega, you stop your video.
Ma'am, I'm unable to stop the screen share. Can you stop it?
Wait, okay. Srinivasan sir.
Stop.
Slide remove pannu.
Can I share my screen, ma'am?
Wait.
Stop.
Can I start? You cannot start screen share. It's coming.
Shobana, you can start. Start your session.
But it is showing that you cannot start screen.
Now you will start. Shobana madam, you will be able to start.
Is my screen visible, sir?
Yes, yes.
Yes, your screen is visible, ma.
Yes, ma'am.
You can use presentation one. Yes,
Okay.
you can present.
Okay.
You can present, ma.
The title of my research is Optimized Multinomial Cancer Drugs Using Multivariate Perceptron with Feature Selection. I'm working as Assistant Professor in Department of Computer Applications in Madras Christian College. I'm also a PhD scholar, and my guide is Dr. N. Priya from SDNB Vaishnav College. The objective of our research is to predict the type of cancer drug when a drug is identified as an inhibitor of cancer. And next is to analyze the performance of machine learning models in multinomial data classification, and then the impact of feature selection on the prediction accuracy. And apply select from model to, it's a technique where we select the most important features, and then to classify the drug type. And because of classification, we can reduce preclinical trial expenses. And this is about cancer. We are going to classify cancer drugs. So when we look into the chart, bar chart, we can very well see this was data given by American Cancer Society year 2020. And we can very well see that the breast cancer, the new cases that can be is around more than 250,000 cases. It's predicted it will be more than 250,000 cases. And leukemia is also high, relatively high, And these two cancers are very common these days. So we are trying to find the drug, like suppose a new drug is found. We want to know exactly to which particular cancer it is beneficial. So introduction, we have got several new compounds which are being synthesized every day with pharmaceutical properties. And among those several drugs, we will have a few drugs that will have inhibition properties against cancer. Okay, if we have so many drugs, then we would, the next step of research would be like exactly what type of cancer it will benefit. It is helping against cancer. Yes, but if I want for a particular cancer, how could I find out that particular drug will be beneficial? And among many types of cancer, identifying the exactly what it benefits is a very challenging task. And in this research paper, we'll be using the machine learning models to classify that to which particular cancer the particular drug falls into. And later we'll be using feature selection, a method called select from model, to enhance the prediction accuracy. So I've taken totally 334 observations, and among that 128 data samples are for breast cancer, and then 91 data samples for leukemia, and the other 115 samples I've taken for other drugs. So it's a multinomial classification. I'll be classifying the drug, whether a newly found drug will fall into breast cancer or leukemia or other drug. I already know it has anti-cancer property, but I want to exactly know like it falls into which type of drug. So the related work, when we see about the past work, they actually most of the researchers, they have taken already existing data from UCI repository. These research papers were like classification of cancer type to malignant or benign. So all of them have taken the same data set, and the samples only vary 699, 569, 683. And they have applied the machine learning models to find whether the cancer is malignant or benign. And with the same data set, the 699 samples, one researcher has found that it is SVM, and the same data set with 569, one researcher has found it is MLP, and the other researcher has found it as KNN. But in our research, we are not taking the existing data set. It's not it is actually primary data set. We are not taking a secondary data set. We actually take the drug names, and we actually get the properties, physicochemical properties, pharmacokinetic properties for each and every drug, and observations are collected manually, and it is not available as a whole. It is not available readily. So where about the data set? So KIG disease database is a Japanese-based database where we have got all information about the drugs and diseases. And Kyoto Encyclopedia of Genes and Genomes is the name of the KEG. And it has got all the drug name available in this particular database are approved drugs. And based on these drug list names, we get the samples from Swiss ADME. This is a very efficient tool where we can compute the physicochemical and pharmacokinetic properties of small molecules. And the data is actually acquired from Swiss ADME. And after applying the feature selection technique, which is select from model, we end up with this 10 major important features. These are the features which we finally get. I have actually reduced it to 30 important features, but here I've listed 10 important features in the diagram. So we choose physicochemical properties, we have drug likeliness, we have pharmacokinetic properties. in all ways we define a drug. So whatever properties are available, we take all of the properties. So when we consider physicochemical properties, we consider the molecular weight, molecular refractivity, polar surface area. And similarly, a drug-like also we have many types of tests. And pharmacokinetic property also, we actually take all the properties available. We are not going to ignore any of the properties. Whatever data is available, we are going to acquire everything. And the methodology is we'll be taking the data samples from CH-EMBL and Swiss ADME. And from this database, we'll be taking the observations. 334 samples were taken, and 47, this includes our type also, target also. And finally, what we do is we directly apply 4 machine learning models: logistic regression, decision tree, random forest, and then multi-layer perceptron. And after applying the feature selection, that is select from model, we actually rank it using an estimator. We rank it using an estimator, and then we find the important features. And with 30 attributes, we again apply it to the machine learning models. And now we see the difference, whether there is any improvement in the accuracy result. And if it is, we find the best model among the 4. So first is we draw the phases of the methodology. Is first we draw the data from the databases. So all the drugs are approved drugs. So we need not worry about the reputation, whether it is authorized or not. It is very much authorized, and each and every drug which has been drawn are approved drugs. And we are preparing the data set with 334 observations and 47 attributes or features. And in this pre-process, we actually convert all the categorical data to numerical data, like high to 1 and low to 0, and S to 1 and no to 0. And all solubility of a particular drug is also converted from 1 to 5, like very soluble, it's mildly soluble. So all those categorical data being converted to numerical data in the pre-processing stage. And later on, once it is done, and once the pre-processing is done, we apply the machine learning models, and then we read the results. So after that, to improve the prediction accuracy, we go for a technique, select from model, feature selection, where we reduce, it's not like reduction, it's exactly like selecting the important features. So we rank the features, we select the top 30 important features, and then we apply the machine learning models again. So now we read the result. We compare the previous result without feature selection, and now after the feature selection, we compare the result with the previous one. And now we select the best model. So after performing all the steps, we found that multi-layer perceptron gave a very good accuracy. So logistic regression was applied, decision tree, random forest, and then multi-layer perceptron. All the 4 models were applied. And the data was divided into 75 and 25. 75 of 334 was, and the remaining 84, that is 25% of 334 was tested. So this is the result. So initially we had 47, and the training accuracy was 0.79, and the testing result was 0.76. And with 30, we got 843, the training, and then testing was 0.78. The logistic regression was the least performing model. And after that, decision tree, so with 47, it had 0.81, and the testing was 0.79. And with 30, the training was 0.85, and then this was 0.81. Random forest, 47, it was 0.87, and testing it was 0.81. And with 30, 0.96, and testing it was 0.82. And multi-layered perceptron, with 47, it was 0.87, and testing it was 0.82. And with 30 features, it was 0.98 and 0.84. So multi-layer perceptron was the best model among all the 4 models. And the metrics were calculated like precision, recall, and then F1 score were calculated. And for all the logistic, decision, random forest, and multi-layer perceptron. And 1 indicates the breast cancer drug, 2 indicates the leukemia drugs, and 3 indicates other drugs. So the conclusion is we took a very normal number of samples, 334 samples were taken for the experiment. The drug was calculated, classified as multinomial, and 4 machine learning models were applied to the data set. And for selecting the features, we use select from model to improve the prediction accuracy. And multi-layer perceptron actually gave a very good accuracy of 84% when compared to other models. And the future scope, so deep learning technique can be employed and incorporated with hybrid machine learning models also. But we require a very large data set. And in the future, we can have a very large data set and work with deep learning techniques. And fine-tuning the hyperparameters also would produce a very good result, would produce a better result, and the prediction will be better, and the classification also will be better to identify facilitate the drug discovery process. And apart from this, novel algorithmic approaches can be done to enhance the performance of the machine learning models. Thank you. Thank you. Thank you.
Okay. So you are concentrated in selection of best drug for cancer types. Am I
Yes.
right?
Oh, yes, sir.
But in general, we are when cancer occurs,
Yes, sir.
a particular part is first identified by
Yes,
doing some diagnosis,
yes, sir.
and there is no common testing mechanism for all type of cancers. So so that is one thing. Another one is why you have not concentrated on particular disease, particular cancer, type of cancer, and inside of that cancer there are different stages are there. Okay, so each and every stage based on the patient, the drug may vary.
This is to look into whether I have the drug. I just know that it stops the growth of the cells. So cancer is something which enhances the cells. It grows continuously. So when I find a drug has anti-cancer property, it means that it is stopping the growth of cells. Okay, if I know that it has, then I want to know whether it will be falling into, it is able to identify which type of cancer I can give. So this is the first step for research. So if I'm having 10,000 compounds, I won't be able to do biological test for each and every compound. So every time I have to spend millions of dollars for each and every biological test. So instead of spending so much of money on biological testing, if I'm able to pick up a few compounds among several compounds synthesized, so that will make my processing biological testing easy.
So what I'm saying is, after confirming the particular type of cancer, then only the treatment will be given. Okay.
Yes, sir. So,
For particular cancer, selective types of selective drugs are available. So from that selective drugs, you can identify that which one is best. But you cannot apply for all type of cancers with the collective drug samples. Okay, so that is my suggestion is you can narrow down, you can take any particular cancer, and you can find the best among several drugs. You can as you said like that, maybe 10,000 drugs may available for particular cancer.
yes.
With the use of machine learning technique, you can find which drug is suitable for that cancer and for that particular patient.
The previous paper, I was working with one particular drug alone. So I was
Okay.
more accurate, precision was higher only. But I want to try whether the same machine learning models are able to classify multinomial. So I was just, this is a research like whether it is going, it can do or it cannot. So previously I was working with only binary values. This is a try,
Okay.
is able to classify or not. That this accuracy is less compared to my previous research. So this is less only.
Okay, thank you.
Thank you so much. Thank you, ma'am.
Thank you, Shobana ma'am. Thank you. Your presentation is nice, and you consider the valuable suggestion which was given to you.
Definitely, yes, ma'am.
Proceed for your further research better, ma'am.
Thank you for wonderful organizing, ma'am. Thank you.
Thank you, ma'am. Thank you very much, ma'am. Okay, the next participant, Sivakumar A, 20 ACIT 55. Are you ready, sir? Srinivasan, sir.
Hello.
Coming for 34. Okay, you can proceed.
Ma'am, today my student, ma'am,
Okay, okay.
solve that student.
Good morning, ma'am. Good morning, everyone.
Morning.
Good morning. Good morning.
I'm Sulaf Muhammad from Syria. I study in Coimbatore, Tamil Nadu in Rathinam College of Arts and Science. Shall I share my screen, ma'am?
Yes, yes.
It is visible?
Yes.
Okay. Today we will talk about a survey on industry specific challenges using big data analytic tools.
So, by L name Bala. F name. But key function la, gonna render argument.
Okay. Shall I start?
Yes.
Yes, start.
Okay.
Please.
Okay, thank you, ma'am. Nowadays, a large volume of data is generated in the form of text, voice, video, images, and sounds. It's a very challenging job to handle and to get process these different types of data. It is very laborious process to analyze this big data by using the traditional data processing application. A huge scattered file system, big data analysis is a difficult task. So to analyze the big data, a number of tools and techniques are required. Some of the techniques of data meaning are used to analyze the big data, such as clustering, production, and classification and decision tree, etc. A huge repository of terabytes and data is generated each day from modern information system and digital techniques such as Internet of Things and cloud computing. Let's start about a small definition about big data. Big data analytics help business and organization make better decisions by revealing information that would have otherwise been hidden. Then we have best big data analytics tool. First one, Tableau. Tableau is extremely powerful. The fact that is one of the most mature and powerful option available shows as soon as you see the available features. It's a bit stupid to learn this platform, but once you, it's well worth it. Tableau has been around since the early day of big data analytics and it continues to mature and grow as an industry. It's extremely innovative and over-comprehensive future. It can plan data in powerful ways because of how flexible the settings are. It has ton of smart features and work at lightning speed. The best of all, it's interactive and can even work on mobile device and share data through shared dashboards. The pros of it extremely flexible when it comes to creating custom visualization reports, powerful engine that can blend multiple data points. The cons of this novel tool for migration and development amount multiple service. The second one is Zoho Analytics. It's a really nice system. There's have been around of a long time when it comes to cream and predictive data. They can handle everything from analytics to sell. The pros of it, up to 10 users are allowed in their free model. Offers comprehensive models. Report are extremely detailed. The cons of this workflow automation is limited to the professional action. The third one is Splunk. Splunk is a great option for a lot of different people. It can handle small, mid-sized and large business enterprises data, as well as public administration, and none provides a single users will as license work for 1,000 to $4.99, and it can be developed on premises through mobile device or even through the cloud. The pros of it adaptable for any organization need real-time monitoring of all data, visual reporting, and analysis. The cons of this list will known that computing models. First one says visual analytic. The visual analysis makes it easy to analyze and share the types of powerful insights compares need into their data. Their models all take their passes in. The pros of it extremely fast, powerful, and scalable, capable of supporting a large number of users, customizable portfolio dashboards for each individual line of business, easy to use thanks to drag and drop feature. The core of this list compatible with external source, then computer platform, and then we have Thailand. The Thailand the Thailand is a great option too. It's an open studio that can handle tons and tons of data using a free license. Its users NoSQL and head up to connect every together. Then we have Cassandra. Cassandra is another free tool to use. The open source software can manage a massive volume of data thanks to the NoSQL DBMS that was constructed. It can even handle data that has been distributed across a variety of different community services. Apache's Cassandra, it's another free tool to use. The open secure software can manage massive volume of data thanks to the NoSQL DBMS that was constructed. It can even handle data that have been distributed across a variety of different community services. It has it's one of SQL Cassandra structured language to interact with the database. The pros of it: handle massive amount of data very quickly, easy to scale in linear fashion, storage along structured automated replication. The cons of this no looking future at the raw level. Then we have Spark. Spark.
Sir?
Madam, are you there?
Are you there?
Yeah, okay, thank you.
Are you audible, ma? Sholab Kamal Muhammad, are you audible?
Yes, ma'am.
Yes. Any question?
Your presentation is not visible here.
Aros. Okay.
Is there any problem?
Sorry, I'm in Syria, so I have some network problem.
Okay. So what is your work?
It's visible now.
Okay, you can go through your go to your contribution slide. Okay, you can tell what is the outcome of your work.
Sorry, my paper is survey.
Either you are going to analyze which big data tool is efficient, or but your title given some other information. It is totally concentrated on industry focus. So now you can tell me either you are going to find the best tool, big data tool for industry applications, or am I audible to you?
Yeah, 1 minute, please.
Okay. can answer the question.
No, I learned in beginning best tool Cassandra and MongoDB.
Okay. So what are all the tools which are freely available for big data analytics? So you have given, you listed 12 tools.
All tools.
See, I raised nearly 4 to 5 questions, but I have not answered.
I say all tools, MongoDB and Cassandra and Splunk, Tableau.
So in your explanation, you said that Cassandra is the tool provided by Amazon. Am I right?
Amazon.
In your presentation, you said that Cassandra is a tool developed by Amazon. Whether it is freely available or we have to pay money for that.
Just now learning, sir, Upshare Cassandra.
Okay. Okay, you go through your area, explore.
Okay.
All the best. Thank you.
Thank you. Sure, sir.
Subair Ali, sir, any question from your side?
Yes, madam. Thank you. Okay. It's not about question. I just would like to comment something about this presentation. Like, so I have seen this presentation from the beginning. So, in what basis that you are trying to analyze and come to the conclusion which tool is the best one? So, I haven't say anything about it at all from the beginning. So in your abstract, I have seen that I don't feel like it's in proper format. Like abstract, in your abstract, you are just trying to big data, what is it, and what kind of tools would be available. What kind of tools is the best for your big data analytics. So abstract is not supposed to be like that, according to my observation. So your abstract should be clearly say what was the previous things and what you are doing and what would be your outcome. So I couldn't, unfortunately, I could not see anything related to my commands. And I also don't understand in what basis you said the Cassandra is the best tool for the big data analytics according to your observation. In what basis you have decided it is the best one? Thank you, sir.
Okay, sir, that will be considered, sir. Your
Thank you, madam.
Next candidate, Pungadi. Pungadi, the participant Pungadi is ready to present the paper.
Ready, ma'am?
Yes, ma'am.
Yeah, present the paper.
Yeah, can start.
Screen visible, ma'am?
Yes, ma'am. Yes, you can proceed, ma'am.
My topic is spam detection in social networks using PSO-based feature selection and deep neural network.
Yeah, hello, sir.
Social network spam is a security problem that involves different techniques. Social networking sites such as Twitter, Facebook, and some enterprises of online network have become extremely popular in last few years. In this paper, the spam command detection system is proposed from the combination of two algorithms, that is particle spam optimization and deep neural networks. Particle spam optimization is used for feature selection and deep neural network is based on the classifiers. Then the proposed spam commands detection system is more efficient and to provide excellent performance in comparison with other methods. Then spam is any kind of unwanted, unsolicited digital communication that gets sent out in bulk. Spam is a huge waste of time and resources, and also increasing in spamming activities affects the people who are using social media adversely. Spammers are categorized into 4 types. There is spammers, teasers, fake users, and promoters. Spammers means the malicious users, the information presented by legitimate users to the security and privacy of social networks. That is a spammers. Teasers means users who behave like a normal user to acquire the personal data. That is a teasers. Fake users means the user who impersonate the profiles of genuine users to send the spam contents. The next one is the promoters. It means who sends malicious links of advertisements or other promotional links. This is the methodology. DSO algorithms, that is used for the feature selection. First initialization steps. We initialize the xi and vi and we have f of xi. Using this initialization and calculate the fitness values. Then calculate b-best and g-best values. Then these steps will be repeated until a stop criterion is satisfied. Then evaluate the fitness value, correct fitness value, then calculate the p-best and g-best values. The next one is the deep neural network based classification. Deep neural network based classification is used for the classifier. The classifier consists of a multi-layer feed-forward perceptron network. This iterations using this values, using these calculations, evaluate the hidden layer inputs. Then backward iterations estimates the input back from the hidden layer using these second equations. Then finally the hidden layer equation is substituted. Then final equation is given the output. After the pre-training stage is complete, use the weights and biases for each layer to initialize the feed-forward neural network. The final classification layers with output for spam and non-spam commands. The network output, the finally calculated as using these equations, the spam and non-spam commands are classified. And finally, we get the result using this SCDS model, SCDS method. This previously existing methods, linear discriminant accuracy value is low 94.1, recall is 95.2, false positive rate 4.36. And then SVM methods, the accuracy value is 95.6, recall is 95.1, false positive 3.98. Then BB neural network, the accuracy is 96.9, recall 95.9, then false positive rate 3.4. Then comparing these methods, the proposed SCDS method is highly, the accuracy value is 98.9, recall 98.7, false positive rate 3.5. Finally, I conclude. An efficient method spam command detection system which combines the particle spam optimization with the deep neural network to classify the commands into spam commands and legitimate commands. Then to improve energy efficiency and throughput without sacrificing accuracy with cost-effective hardware or critical to expanding the deployment of deep neural network in both existing and new domains. The proposed SCDS method shows a better classification performance when compared with other classifiers. Thank you. Thank you, ma'am.
Okay. So what is meant by deep learning?
It is a artificial neural networks with multiple layers between the input and output layers to share the output.
Have you implemented the existing paperwork as implementation, or you have done any contribution, you have given any contribution or proposed methodology you developed in this work?
Yes, sir. I propose the methodology to using the deep neural network to improve the most of the existing methods deal with the detection of anomalous users or spam nodes, but the attackers can create multiple accounts and continue the performing malicious activities. So here we use these methods, I get the best result.
What is the application area of your work? Where we can use this your work?
Social networks, the Facebook, Twitters, Messengers, LinkedIn, for all the social networks, I use the applications.
No. I am asking about what is the benefit. So you are finding spam messages.
Yes, sir.
In social network.
Yes, sir.
So what is the purpose of finding that spam messages?
Sir, different level of success being achieved, sir. Either the solitary or combined techniques.
So who is the beneficiaries of your work?
Sir?
Who will get benefit?
Sir, before that existing methods didn't provide the any hello?
Yes. You can proceed. So I am asking about what is the application area. Okay. Thank you for your presentation. Thank you.
Okay, sir.
Any other questions?
No, sir.
So I am asking the participants or visitors. If you have any questions, you can ask.
Okay, sir. Thank you very much, sir. Sir, and another two participants, due to some medical reason, they are not unable to attend our conference. Okay, sir. Thank you very much for your valuable suggestion and your valuable queries. And we thank you once again, sir. Thank you very much.
Thank you, ma'am. Thank you.
Dear participants, afternoon 2:30. You think that right? 2:20. 2:20 again. Please get in Zoom link. 2:20. Bhuvan Helker, USA, from USA, he is giving a keynote speech on key considerations in the use of data for security analytics. So everyone, please get inside around 2:20 in the Zoom link. And following that, the technical session will be continuing. Thank you. Srinivasan sir. Srinivasan sir.
End பண்ணிடலாமா மேடம்?
Now we can wind up the session, sir. Again 2:20, please, we have to get in, sir.
Okay, madam. Thank you.
Thank you.